Welcome to my channel Phi Concepts CHM. This is the seventh part of the series of thermodynamics. In the last video and before that also, last two videos we had seen the applications of first law of thermodynamics. So two applications we have seen. Now we will see the third application, work done in an isothermal process, and the fourth one, work done in an isochoric process. Third application, work done during isothermal process. When a gas is allowed to expand isothermally, the work is done by the gas. Let the initial volume be V1 and the final volume be V2. You can see that in this diagram, V1, V2. Area of the shaded strip, that is this part, represents the work done for a small change in volume dV. When volume changes from V1 to V2, work done can be given as integration of P dV with limits V1 to V2, and it is equivalent to the area under this curve, that is ABDC. Consider 1 gram molecule of gas. We can write down the ideal gas equation, PV is equal to RT. From this we get P is equal to RT by V, that you can substitute in this equation. RT is a constant, so it is taken outside the integral. So inside the integral we have dV by V. So we'll have to integrate this. We get the integration of dV by V will be ln of V, and then the limits are substituted, upper limit and the lower limit. So you get ln of V2 by V1. This is the final equation, RT into ln of V2 by V1. Also it can be written as RT into 2.303 into log to the base 10 of V2 by V1. Also P1 V1 is equal to P2 V2. Rearrange the equation to get V2 by V1 is equal to P1 by P2 at a constant temperature, as it is an isothermal process. So we can substitute V2 by V1 here in this equation or in this equation. So that will be W is equal to RT into ln of P1 by P2. So this equation we got in terms of volume, and this is the same but in terms of pressure. For ideal gas, the internal energy U is a function of temperature alone. In an isothermal process, the temperature remains constant. Therefore, the internal energy U is also a constant. Therefore, the change in internal energy dU is equal to 0. From the first law of thermodynamics, that is dQ is equal to du plus dW. Now du is 0, therefore dQ is equal to dW. Therefore, the heat supplied is equal to the work done by the gas. Therefore, the heat added to the system goes entirely into doing the work for the expansion of the system against external pressure. Fourth application, work done in isochoric process. Isochoric process means the volume remains constant. That is, the change in volume dV will be equal to 0. So the work done by the system in going from state 1 to state 2 will be given as W is equal to integration of P dV. Now as dV is 0, so the work done is 0. The first law of thermodynamics is Q is equal to delta U plus delta W. Here now delta W is 0. Work done is 0. Hence we get Q is equal to delta U which can be written as U2 minus U1, the change in internal energy. These U1 and U2 are the internal energy of the corresponding states. Hence, we can conclude that the increase in internal energy of a system is equal to the heat absorbed by it. So, this was the fourth application. The fifth application is the work done in adiabatic process, and the sixth application is work done in an isobaric process. The link for both the applications is given in the description box. You can check out. Thank you for watching this video.